Graphic projection of lines. This is the fifth part, line inclined to both the planes. Here we will be showing you the two-dimensional drawing in three-dimensional environment. So it can be done in 5 stages, starting from parallel to both, then parallel to HP only, and VP only, then mad inclined to both HP VP or VP HP. Actually 2 and 3 can be drawn directly stages. 4th and 5th are complementary, that is any one is completed, we can have enough data. 5th one is generally used to verify our problems. So let us start with a line parallel to both the plane, and in 2-dimensional, first the point A will be plotted, that is A dash and A. Rule number 1, applying rule number 1 because it has to be perpendicular to XY line, and the line is parallel to both the plane. Plan and elevation both are parallel and equal to true length, and B dash B can be located. Now next we will draw line inclined only to HP. So true length will be, true inclination is visible in the front view, and true front view is equal to true length, and the corresponding inclination is 28 degree is drawn, and its corresponding projection will be A B1 dash, A dash B1 dash, and A B1. So A B1 will be parallel to XY as per rule number 3, so it can be drawn. So both get intersected, that is the point B1, because we have the convention of A B1 is a line inclined to HP only. So this is what drawn as a second layer, but generally in the paper it will look like this. So we have enough data to draw directly inclination to HP, so we can remove a line parallel to both the planes for clarity. Likewise, now we will be drawing a line inclined only to VP. Same procedure, and it is visualized in another layer. Inclination, true length in the plan, corresponding projection in the elevation. So whenever you see these type of diagram, actually it is overlapping of 3 or 2 diagrams. Inclined to parallel to both the plane is removed, so it's overlapping of 2 diagrams. 2 stages of lines are drawn, inclined to HP only and inclined to VP only. Now we can achieve or reach a line inclined to both the plane from B2 dash, that means inclined to VP first, then we are making inclined to HP. So inclined to VP, projection is B2 dash, we are reaching the B3 dash. So now we need where to stop this line is nothing but that locus or the boundary plane which we have mentioned, because capital B3, the coordinate of a line inclined to both the plane, in the fixed point is A, the moving point, the other end point is B3, will have the same coordinate whether you are reaching by B2 to B3 or B1 to B3. And this locus B1 to B dash, B3 dash, this locus is nothing but the boundary plane, which can be calculated provided if you draw a line A dash to B1 dash. That's why even though if we are going by B2 dash to B3 dash, to find the locus or where to stop this B3 dash, we need the boundary plane height or the locus line B1 dash to B3 dash. That's why we should draw two stages independently, and it is mandatory to find the B3 dash, because we are rotating A dash B3 dash B2 dash, which is actually not a true length, so it's a projected length. If a true length, we can give true inclination, but it is a projected length, we don't know where to stop. That can be only achieved provided if you know the locus B1 dash to B3 dash, which is the boundary plane. Same way we need locus in the other direction when you go from B1 to B3. So once B3 dash is drawn or achieved, we can draw B3 also. B3 dash is known, B3 will be in a straight line which is perpendicular to xy, and easily you can locate it. With that we can complete the problem. But B3, B2 to B3, that means line inclined to B2, inclined to HP, then VP, also can be drawn in the same way provided if you know the other locus or other boundary plane. So it is a complementary one. You can start from B1 to B3 or B2 to B3. You can find enough data. Any one can be drawn, but generally the other method is drawn, and it is the problem can be verified whether it is we have done it correctly or not. So this is the way. B2 to B3 problem is over. But B1 to B3 also, if you draw, it has to exactly intersect with the B3, because B3 is achieved from B3 dash, and when you find B1 to B3, it has to exactly intersect with the B3 which was deduced from B3 dash to B3 as a projector. B1, B2 to B3 is we are moving in an arc-like manner. At that time also it has to get intersect with the B3 which was deduced from B3 dash. The other way also we can do it. From B1 to B3, first complete it, find the B3 dash, and if you draw an arc from B2 to B3 dash, B2 to B3 dash, so at that time also it has to intersect accurately, so that we have done it correctly. So this is the line inclined, projection of line inclined to both the plane we used to draw in a paper, which can be visualized as minimum of 4 layers. Now you see B2 dash, A dash, B2 dash is equivalent to A dash B3 dash. A dash B2 dash is a projected length when the line is inclined to VP. You see, same length. So it gives the relation between the stage when it is inclined to one plane and when inclined to both the plane. So inclined to one plane is A dash B2 dash. Inclined to both the plane is A dash B3 dash. Both the time the magnitude of or length of the line is same. When it is inclined to one plane, it is parallel, but it is inclined to both the plane. Front view and top view both are inclined to xy. If it is inclined to any one of the plane, one of the projection will be parallel. Same way it can be visualized for other projection also. So this is alpha, apparent angle, and this is beta, another apparent angle. So the final front view makes inclination with xy is alpha, apparent angle, and the final top view makes inclination with xy is beta. Both are called as apparent angles. It's visible, it is available only in the paper, not in the space. Thank you.